I conducted research on how climate is impacting Florida scrub hatch success. Climate change is a global issue. Some of the more noticeable effects include sea level rise, droughts, range shifts of species, and changes in phenology. Because these changes are happening at a much quicker pace than they normally would, many species are unable to adapt and are being negatively impacted. Of these, some of the most notable are polar bears, corals, and monarch butterflies. Each has been directly affected by rising temperatures. Polar bears were the first species in the US to be listed under the Endangered Species Act because of climate change. They rely on ice sheets to hunt, and as these disappear, they're going hungry. Corals rely on a symbiotic relationship with algae to produce food. They're easily stressed by warmer ocean waters, and their first response is to get rid of the algae they rely on. This eventually causes their death. Monarch butterflies are very sensitive to weather. They use environmental cues to initiate important life events, such as migration and reproduction. The Florida scrub jay is one such species that could be impacted by climate change, although we're not exactly sure how. It's a Florida endemic and lives only in scrubbed habitat found in the peninsula. Partly because of the loss of this specific habitat, it's federally threatened, so we're interested in studying its survival. Scrub jays are birds that live in small groups with a breeding pair and several helpers. They defend territory year-round and build nests only within their territories during the breeding season. This occurs from March to June. While this means they experience a large range in temperatures, any changes could affect nest success. The map on the right shows territories and nests of scrub jays on Archbold property in 2019. One area of concern is the high failure of nests. Although nest failure is not uncommon among passerines, it's important to understand all aspects of life history in order to conserve the species. Some territories have only one nest. This is because they are successful on their first attempt. Scrub jays do not generally re-nest in a season after they successfully fledge young. Others end up building multiple nests as they fail. With each subsequent failure and nest attempt, it gets later and later in the season, and we know from previous studies that the probability of success decreases the later the nest attempt occurs. We also know that nest success has been decreasing over the past 40 years, and we're not sure what's causing this. For a nest to be successful, they have to hatch and then fledge. Because I was interested in addressing how climate is affecting the birds, I looked only at the egg period, which includes the time up until they hatch. Eggs are more affected by temperature changes compared to nestlings. Scrub jays build open cup nests. These consist of a stick platform and are lined with fibers from palmettos. Because the nest allows eggs to be exposed to ambient temperatures, it's difficult for the nest alone to regulate internal temperatures. Therefore, they rely on incubation to maintain the proper temperature. The more consistent the incubation rhythms are, meaning fewer and shorter off-bouts, the greater the likelihood of success. Because incubation is so important, I wanted to know if climate affected incubation rhythms or the effectiveness of incubation. To do this, I used iButtons. Each iButton is a computer chip enclosed inside a steel container. The ones I used recorded temperatures at set time intervals. They're useful to researchers because they can be left in the field for long periods of time, allowing data to be collected relatively passively. I painted them so they would blend into the nest material and attached a wire so I could secure them to the nest and the birds would not be able to remove them. I placed control nests nearby to compare temperatures between a nest that is being incubated and one that is not. Unfortunately, the birds did not appreciate my efforts and abandoned nests I placed iButtons in. Because concern for the birds was a priority, I switched focus towards looking through 40 years of nest success and weather data from 1981 to 2019. Although I could no longer study incubation rhythms or the microclimate of nests, I could ask how climate was affecting scrub jay nest success during incubation. Basically, I believed that the extremes, higher highs, lower lows, and intense precipitation would have a negative impact on hatching. Possible explanations come from the egg viability hypothesis. This states that eggs exposed to warm temperatures before incubation have a greater chance of failure. This could be because warm ambient temperatures can cause eggs to begin developing before they should. Since the jays are synchronous hatchers, this presents a problem, allowing some eggs to be more developed than others. Warmer temperatures also promote bacterial growth on the surface of eggs, which has been shown to decrease the chance of hatching. Additionally, eggs are sensitive to temperature changes. Anything that differs too severely from physiological zero, 93 to 97 degrees Fahrenheit, could kill the eggs, so especially hot or cold periods could be lethal, with hot temperatures being more dangerous. I started by dividing the breeding season into 2-week intervals, starting from the earliest incubation date to the latest fail date across all years. This left me with 9 2-week periods, although I ended up ignoring the last period since only a few nests were still active this late in the season. I calculated climate data for each period each year. These included average highs, lows, amounts of precipitation, as well as highest highs, lowest lows, and greatest amounts of precipitation during the 2-week periods. To study incubation success, I calculated daily nest survival for each 2-week period using Mayfield's equation. This is 1 minus the number of failed nests divided by the number of exposure days for all nests, where exposure days are the total number of days a nest was active. It's important to account for this because not all nests were active for the same amount of time during each period, and it would skew the results to compare a nest that was active for 1 day to one that was active for 14. I also found the proportion hatched. So if a nest hatched during a 2-week period, I divided the number that hatched by the total number of eggs laid. Just to recap, I thought that all of the weather variables would be negatively correlated with success, both proportion hatched and daily survival. For example, an increase in average high would decrease the proportion of eggs hatched. This shows the hatch proportion by 2-week interval. As you can see, it declined throughout the season. After running an analysis of covariates, it turned out that lows and weak impacted proportion hatched. The graph on the left shows temperature as a red line and proportion hatched as bars. Temperatures increased as the season progressed, while proportion hatched decreased. The same happened for precipitation. In each of these cases, analysis showed that weak had a stronger effect on hatching than the weather variable. So when considering highs and weak predicted hatch rates better. Since the important variable was weak, we know that hatch rates are changing throughout the breeding season and that this does not appear to be caused by either highs or precipitation. However, when including lows and weak as covariates, lows had a stronger effect than weak. This basically means that a low affected hatch rate similarly if it happened early or late in the season. The relationship between lows and hatch proportion was best shown by a quadratic curve. These graphs show that when a low is too high or too low, hatch proportion goes down. Since lows appeared to have an effect, I then wanted to see if there were any trends in lows over the past 40 years. To do this, I ran a linear regression to see how each change in year affected low temperatures. Because these linear models were insignificant, I could infer that lows have not been changing over time, or at least not over the course of this study period. When it came to daily survival, none of the weather variables I looked at had an effect. There was also no seasonal effect. Daily survival stayed mostly the same over the course of the breeding season, and there is not much variation. The range across all years for daily survival was just 95 to 99. I'd like to point out that although this seems like a very high chance of success, daily survival does not necessarily mean eggs will hatch. The nest must survive 18 consecutive days of incubation. So even a 97% daily survival rate has only a 58% chance of hatching. Although it did not appear to be affected by weather or time in breeding season, daily survival has decreased since the 80s. So my results showed that lows and weak impacted hatch proportions, with moderate lows and earlier weeks being best for hatch success. Daily survival did not seem to be changing with weather or time in breeding season, but has decreased since 1981. Since it doesn't appear to be caused by climate, this could be good news for scrub jays with respect to global warming. However, it is still an area of concern and should be studied further. My analysis suggests that lows have an impact on hatch proportions and that there is a range of temperatures that is ideal for hatching. Since lows have not been changing over time, this again could be good news and could mean that climate change is not expected to have major impacts on scrub jay incubation. Since time and breeding season had a significant impact on hatch proportions, we know they're changing throughout the season, but it did not appear to be affected by climate. However, the R-squared values were low, with weather only accounting for about 5% of the variation. Other factors affecting incubation include predation and incubation rhythms, and these could be having a bigger effect than weather. So there's still a lot that could be studied with respect to nest success. Other than direct effects on eggs, temperature and rainfall could affect the behavior of predators or of the brooding females. Snakes are a major nest predator and may not be particularly active earlier in the season when it's cooler. Additionally, we know that the less time a female spends off the nest, the greater the chance of hatching. Cooler temperatures or better food availability can encourage and allow the female to stay on the nest longer without having to get it as frequently or for as long. For this project, I didn't look at the nestling period. Although they have a better chance of fending for themselves, especially the older nestlings, they're still vulnerable to the same temperature and rainfall extremes eggs are. Since females invest most of the energy towards reproduction, I'd be interested in seeing how female body condition affects the eggs. It could be that food availability over winter is important for nest survival the following breeding season. And I think it'd be really interesting to study the geographic distribution of nest failures. They appear to be clustered in some areas, so I'd like to figure out if this is random or if there's some cause and what that could be. If a pair fails in one area, are they more or less likely to re-nest far away? Are the birds in those territories simply worse at building and defending nests? Or do neighbors affect failures, and is this a density-dependent effect? I'd like to thank the Bird Lab, Joe, Vivian, Daniel, and Archbold in general for hosting me and supporting me throughout this process. Through this opportunity, I've learned a lot about research and a unique species. Are there any questions?
Thank you, Joelle. That was great. Let's go on to a few questions. So someone asked if there were other ways to measure nest temperature that didn't impact the jays in the nest.
Right, so there are other temperature monitor or little temperature probes, but I only had the eye buttons available. So when that failed, I had to just abandon that project.
Okay. Another question from Toby Shea, who's a former intern. Might fluctuating food availability, for example, prey insect abundance due to climate change, affect the metrics you chose to measure for this study?
Well, I did think that maybe the body condition of the adults would affect this. And so if the insect availability affected that, that could have an impact.
Yeah, let me just check it. It's like there's some in the chat. Someone, Eva Reyes asks if you could hypothesize on the possible failure causes.
It's really hard to know this because when things die in nature, it's really hard to track that because it just kind of happens and then we come back later and notice that the nest was predated. And so it's really hard to look at this. I think it'd be really interesting if we could put cameras on nests, but yeah, we didn't do that.
Okay, well, I don't think I see any additional questions, so I'm going to turn it back over to Laura. Joelle, thank you very much.